Hello everyone. Today I am going to start new chapter of physics, chapter 9, force and laws of motion. In the previous chapter we have studied about equation of motion, acceleration. Here in this chapter we will about force and three laws of motion. Aristotle, he told about natural state of bodies is at rest. Galileo, he told about natural state of bodies, it may be rest or in motion at constant velocity. Now my main idea to tell you this thing here is mathematical derivation was done by Galileo, Aristotle, Copernicus, and physical interpretation of this is done by Isaac Newton in the form of three laws of motion. Other than this, Isaac Newton also invented calculus and he discovered universal law of gravitation that we will study in next chapter. These three laws of motion are very important because they are fundamental of classical physics. Now when you say force, this term when comes to mind, what you think? It is a push, pull. Next you see these pictures. This picture, this ball, this girl is applying force on this ball and there is change in position of this ball. Here force is applied to this ball and there is change in shape of the ball. Here pulling, this is also type of force. Here force is applied to break this brick. That means when we apply force, force may change position of the body, it may change size or shape of the body, it may break the object. Okay. In a very simple language, you can say a force is a push or a pull. But as of now, this definition is okay. But as we study these laws of motion, we will come across more precise definition of force. Okay. Now, balanced and unbalanced force. So you have a box over here. And you are applying force from this direction and your friend is applying force from this direction. Equal. Your force applied by you and your friend is equal. So now what will happen to this box? It will not move. Okay. So net force here is 0. So situation where net force is 0 and there is no change in position of the object, this type of force is known as balanced force. Okay. Now let's say you are applying 10 Newton force and your friend is applying 8 Newton force. Now you have 2 Newton force more. So this box now it will shift to this direction. It will come over here. Okay. In this case there is change in position of this box. So in this case the net force is not 0. It is 2 Newton and this type of force is known as unbalanced force. So whenever there is unbalanced force, there may be change in position of the body or direction, or a box may come in motion. It may speed up, it may slow down. Okay, but in case of balanced force, there is no change in position of the body. Net force remains 0. So the definition of balanced force, it does not cause change in motion and the forces on that particular body are equal in size and opposite in direction. So they cancels out. Here I have given some examples of balanced forces. In each and every example, forces are equal and opposite. So net force on these objects are 0. Unbalanced force, when one force is greater than its opposite force. So there is some net force. So unbalanced force, what it can do? It can cause object to speed up, slow down, stop or change direction. You can see these two cartoons. He is having more force, so he is pushing him down. Some more example of unbalanced force you can see in this picture. Here 50 Newton, 30 Newton. So this side it will go. Similarly here it will go downwards. So the object will move in that direction where there is more force. So these are the examples of unbalanced force. Only this much for today. What you have to write in notebook is simple definition of force, that is pull and push. You have to write definition of balanced and unbalanced force from slide with just write at least 1 or 2 more examples. And in the next lecture I will start with Newton's law of motion. And please, this chapter is very important, basic chapter. So read it and understand it properly. And if you have any doubt, please tell me. Thank you.